Morning. I wanted to start by going over this first example in your notes. I know you used the book to get you started, but I just wanted to take you through some of the reasons and methods. So linear methods, basically your goal is to get the trig function all by itself. So we can start by subtracting the root 3 to the other side and then dividing out the 2. So what that gives us is a simple trig equation. We want to use the negative here and the ratio to determine the quadrant in which theta is going to live. So sine is negative in the third and fourth quadrant. So I'm just drawing these little terminal rays to help me remember that my final answers are going to have to be those angles that live in the third and fourth quadrant. And the next thing I want to do is I want to find the reference angle for the root 3 over 2 sine. And so that's going to occur, let me write that, that's going to occur at pi over 3. So we're going to insert that pi over 3 into the third quadrant, and that's going to give us an angle of pi plus pi over 3, or 4/3 of pi. And then we're going to do the same thing into the fourth quadrant. Oopsie, that should be a pi over 3. That's really unattractive there. Sorry about that. So that's going to be a pi over 3 as well. Because I'm asking you to solve for all theta in radians, you have a choice. You could either call that negative pi over 3, or you could call that 5 pi over 3. And that's determined by taking the entire revolution of 2 pi and then backtracking or taking away that pi over 3 angle. And that's going to give you that 5 pi over 3. So the last thing we want to do is solve for all angles. So if you think of the graph of sine theta, let me just do a real quick sine theta graph, definitely not drawn to scale. There are lots of places where the graph intersects the line of negative root 3 over 2. And I want to find all of those values. So I know from the wrapping function that if I add a revolution to 4 pi over 3, it's going to take me back to that third quadrant angle. And I want to do that all the time. So I'm going to multiply 2 pi by some integers. So I do want to indicate that n is an integer. And I can do that here if you chose to do the negative pi over 3, and here if you chose to do the 5 pi over 3.